So June 2018, and I love this question. It's kind of fun. They don't come up very often. You know, you look at this and I see immediately is cobweb or staircase. It's one of those ones, and you kind of think, oh, I hope they make me draw it, or I do. But the first question, the first part, let's have a look. So the curve with equation y equals 2 ln 8 minus x meets the line y equals at the point theta, where x equals theta. Show that theta lies between 3 and 4 is what that's saying at part A. So they're telling you it lies between 3 and 4. So what we normally do with these would be rearrange the equation, make it equal 0, find the value at 3, find the value at 4. There should be a change of sign and the function is continuous, so there would be a root between those two. That's what we need to do. So it's recognising that that's what they're looking for. And part of this question is saying that. The second part is saying change of sign and the function is continuous, so that in the interval between 3 and 4 there is an answer, there is a root. Because this is our iteration, we're kind of guessing, stepping towards the solution of that equation, 2 ln 8 minus x. Let's see what the equation is. So let's have a look. So we've got the equation y equals 2 ln 8 minus x. Okay, and we've also got the equation y equals x, and we're saying, so they meet together, so we're going to make them equal. Okay, so we're going to have 2 ln 8 minus x equals x, so then 2 ln 8 minus x, we're going to say is a function of x. And what we are saying is that there's a solution to this equation between when f is 3 and when f is 4. Okay, that's what we're trying to do. So if I get my calculator, let's write it out first. So you've got 2 ln 8 minus 3 minus 3, and then you've got 2 ln 8 minus 4 minus 4. Let's see what those values are. Okay. Oops. Okay, so 2 ln bracket 8 minus 4 close bracket minus 4. Don't know whether I did that one first. Minus 1.227411278. I'm going to go back up and just change the 4 to 3. And I get 0.218875824, and then hopefully, come on. Hopefully you can see 49, lovely. That one is positive and one is negative, which is what we're looking for. If there isn't a change of sign, there is a problem. You've done something wrong. So we can say there is a change of sign. So change of sign is one thing they always look for. If you look at the mark scheme and they've underlined something, that needs to be there to get that mark. So there is a change of sign and the function is continuous. Therefore, there is a root in the interval. So 3, 4. Now square brackets like this show you that it's an interval and equal and up to, and no, not equal to 3 and 4, because that's what they said, wasn't it? Between. There you go, between 3 and 4. So that's what that means. So there is a root there. The other thing, actually, given I'm writing in here, never write outside of the lines. If you do, you're going to have to put a big asterisk somewhere so that they see it, because these are scanned and we don't see the bottom of the page when we're marking them. So be careful on that. Right. So that's, and believe it or not, that is 2 marks. You get 1 mark for substituting in the 3 and the 4. And you get a 1 mark for getting your answers, showing that there is a change of sign and that it's a continuous, remember, continuous group. Right, okay. Figure 2 shows the graph. The student uses this iteration. okay, which is just where they equal each other. In an attempt to find the approximation using the graph starting with x is 1, determine whether or not this iteration formula can be used to find an approximation for this. This is us drawing the graph, okay? So I'm going to get my straight line in blue, and I'm going to go, so what you do is you sub it into the equation. So the equation that we're subbing into, there we go, is the 2 ln 8 minus x. And then whatever answer we get out, we then use, we put it back into the y equals x, and we get out our next x answer. Now you don't necessarily, I'm going to do this, and then you don't necessarily need to, oops, do this again. So that's our next x, okay? And then we put that in to the equation. Okay, so we're going to go, oops, I'm going to go x1, we're going to put that into the equation that we're trying to solve, this one. We're going to get out an answer, and then we're going to put that back into, if I get a nicer colour, same colour, into our y equals x, and this will give us the next x value that we're going to put. So that's what we do. Whatever we get out, we then use as another value that we're going to input into the equation to come up with an estimate. Okay, let me change my colour again. Okay, then we use that and we go up to the curved line and across. And that's our, whatever we get out is y, obviously, but then we're going to use that to go back into the, change it y equals x and change it to be an x value that we can use. So that would be my third estimate. And, oops. And then for my third estimate, I go up to the graph, to the curved graph, come off, and then go back in to the XY. Oh, we're getting much closer now. And that would be my next estimate. Right, that's the theory behind it. Let me show you what's easier to do. And we'll see. Okay, so what you do when you're doing this, that is the theory. Okay, that's what the line means. So you go into the curve, then to the straight line, then to the curve. Oh, that wasn't very good. I might redo that one. Then to the curve, still not great. Then to the straight line, then to the curve, then to the straight line, curve. So this isn't a staircase. This is a cobweb. Can you see that? And that's what we're saying. So if you added in all my other lines there, if I go back, so keep that in mind, and if I go back, oops, I have drawn exactly the same lines, but I'm going to change this to white now, and we're going to, so we put in the 4, got out the 4, but I added this extra line. So if I get rid of that, you'll see, there we go, if I get rid of that, that's where we went. Then I went up to the thing and I would have got rid of that, and across, and hold on, up, in, up, so we didn't need that bit, and we didn't need that extra, oh we did, no we don't need that extra bit, or that extra bit, or that extra bit, but you end up going round, so it works the same. So what you do is you say, so you don't need that bit either. So you do curve, straight line, curve, straight line, curve, straight line, and you go round so that you end up as a cobweb for this one. I've got one too